As a part of TENSOR project, Fujitsu is developing visual-based gait recognition module. Gait refers to the specific way an individual walks or moves on foot. This includes a variety of characteristics such as the rhythm, speed, stride length, and overall body posture during the act of walking. While Gait offers a unique biometric identifier, it is considered less reliable compared to other biometrics utilized in TENSOR project. The challenges stem from factors such as environmental conditions, changes in a person's physical condition, and the variability in gait patterns among individuals, which can impact the system's ability to accurately and reliably recognize individuals based on their walking patterns. Despite these challenges, recognition holds a significant advantage: its capability to identify individuals at a distance where other biometric features, like facial recognition, might not be feasible. This attribute makes Gait an invaluable addition to biometric identification, especially in scenarios where individuals cannot be directly or closely monitored. In our gait recognition tool, we employ an SOTA-based approach for recognizing gait patterns using the Gait mixer model. This model distinguishes itself by relying on skeleton-based recognition rather than conventional appearance-based features, focusing exclusively on the patterns of skeletal movement. The input of the system is a video. The process begins with person detection and tracking, utilizing the advanced capabilities of a YOLO model. This is complemented by a tracking system that maintains identification of the individual throughout the video sequence. Following detection, we apply MediaPipe, a state-of-the-art posture recognition model, to accurately identify and extract the 3D coordinates of skeleton joints from standard CCTV footage. This critical step allows us to capture the essential skeleton sequences needed for further analysis. These extracted sequences are then processed by the pre-trained Gait mixer model, which generates a unique 128-dimensional gait signature for each individual. This signature serves as a robust identifier for gait matching purposes, and cosine distance is used as a distance metric. During the first year of TENSOR project, we experimented with both SOTA deep learning-based and hand-featured gait recognition algorithms. Based on our experiments, we selected the best approach for the TENSOR gait recognition platform presented in the previous slide, and we are currently working on further improvements. Add the projection or use 3D skeleton features as inputs to the gait description model. Use a unified FPS, frames per second, for all videos. Select the best part of the video for gait descriptor calculation based on the model's confidence. The input of our module is a CCTV footage data. Here we see a video with a single person walking. However, multiple individuals can be present on the video, and gait signature will be extracted for each person given that the resolution is enough to reliably estimate skeleton joint positions. The primary gait recognition module output is a 128-dimensional gait signature vector. Additionally, we can extract more gait features from the resulting skeletons of posture estimation, though our findings indicate these are less distinctive. The additional handcrafted features are height, skeleton joints positions, lengths of body parts, limbs flexion angles. Limping can be indirectly estimated by the acceleration of the limb joints and limbs flexion angles dynamics. Mean step width, mean step time, cadence, acceleration of points. Gait biometric can be used in use case 1 and use case 2 scenarios described in TENSOR project. Gait, as an additional biometric feature, provides a unique advantage for identification and security purposes, especially when other biometric features such as fingerprints, facial recognition, or behavioral patterns extracted from smart devices are not available. Gait biometrics can be extracted from CCTV footage data. It can be an additional level for person identification results when the other modalities are available.
Let's now start the demo. One can use pre-recorded videos or live video streams. You can switch between the two using these buttons. Let's start by a video, and add a new person to the Gait database. For that you need to first upload a video with a person walking, like so. When the video is uploaded, the AI algorithm is detecting the human and tracking the individual throughout the video. Human posture is estimated on each frame using the media pipe, and resulting skeleton sequences are used as an input for Gait mixer algorithm. The algorithm is taking the best 60 consequent frames. The selection is made based on the confidence of the posture estimation model. Once the Gait signature extraction is done, we can add the newly obtained Gait signature corresponding to this video to the database and give it a unique ID. Currently, our database contains about 20 individuals, captured in our office in Paris. Let's add one more person, and an ID, Jonas. Here I am typing the name and confirm. The person is now added to the database. Let's add another one. Note that the direction of the walk is different this time. Behind. The video is processed just as the first one. Let's assign a new ID to the person. And here is another person that we can add. Let's add one more individual. Let's add last individual with other gender and other direction. Now, let's try to find a match between the person and the database. We are selecting a new video. This time, we want to also match the person to the database that we have. The video is processing in a similar way as before, and then a search is made with all the IDs registered in the database. Cosine similarity is used to compare the new Gait signature with the DB ones, and the closest match is returned, along with the matching distance. Here you can see that the returned ID is correct, and an image of the query and result. Let's try to make one more test. Here are other match between the query and the database. Now you have seen the demo we prepared specifically for the TENSOR project, demonstrating how our Gait signature extraction and reconstruction component works. This is currently a work in progress, and we hope to further improve this technology before integrating it into the TENSOR platform. Specifically, we are exploring ways to retrain Gait mixer with more data. Use projection prior to Gait mixer to make the Gait signature more robust against changes in view, and experiment with silhouette-based Gait descriptors. Please note that this is a demo tool we made for TENSOR. The real module is to be integrated to the platform in the near future. Thank you very much for your attention. We would be happy to answer to your questions.